This is a lecture on law of cosines. I'm going to start with a regular looking triangle. I'll label this as A, B, C, capital letters. Side that's opposite of angle A is little a. Side that's opposite angle B is little b. Side that's opposite angle C is little c. I have the following three expressions as part of my law of cosine. A squared is equal to b squared plus c squared minus 2bc, cosine of A. I can also rewrite this: b squared is equal to a squared plus c squared minus 2ac, cosine of B. You'll use this when you have a different angle that you are able to use. And c squared is equal to a squared plus b squared minus 2ab, cosine of C. We'll try to prove this right now. I'll start with my picture of my triangle. I'll label those A, B, C. I will drop a height from the angle C to the side that's opposite, which is little c. I'll also label this particular point as point D for reference. The side that's opposite of angle B is little b. The side that's opposite of angle A is little a. This side will be labeled as x, and the side that's on the other side is c minus x. I will end up with two right triangles. One of the right triangles is outlined in green, and this is my height. I'll label it as h. I'm able to use a Pythagorean theorem right now, because one leg squared, the other leg squared is equal to the hypotenuse squared. So I'll end up with h squared plus c minus x squared is equal to a squared. I'll open the parentheses. So h squared plus c squared minus 2, I multiply the two together, plus the square of the last thing is equal to a squared. I also have another triangle which I will outline in below. This is also right triangle because of the altitude that's being dropped from angle C, the height. So I can construct another Pythagorean. I can use the Pythagorean theorem again to construct another equation. So I'll have h squared plus x squared is equal to b squared. Notice that I have the h and the x in here. So what I can do is I can replace these two with a b squared. So instead of this equation, I now will have b squared plus c squared minus 2xc is equal to a squared. Now I like all the a's and b's and c's, and the 2 is fine. It's starting to look exactly like my law of cosines right about now, but I need to replace x with something with expression of cosine. So I'll take a look at my ACD triangle, my blue triangle. I can see that the cosine of A is adjacent over the hypotenuse, so it's x over b. If I multiply both sides by b, I'll end up with an expression in terms of x in terms of b and the cosine of A. So x is now b cosine of A. I can take that and plug it in exactly where I have the x. So I'll end up with b squared plus c squared minus 2. I'll put in the c here. Put in the b here, c cosine A. So you have your 2, you have your c, and then the b cosine A is equal to a squared. This is one of the expressions. In particular, this is the first expression. Similarly, I can drop the height from angle A or angle B to get the other three equations. This is it for the proof.